Hello dear friends, welcome to Gate Academy Global. So before starting today's video, I would like to take the concurrence as well as the feedback from each one of you. The quality of video as well as audio, is it perfect or not? If it is perfect, just write perfect over the live chat. So at least I'll get to know that each and everything is perfect. Before starting today's session, I would like to give a brief information. Our great Dande sir is taking marathon on our main channel. So the person or the student who can understand Hindi very well, just tune into our main channel to have the great feeling of the control system. So probably the marathon already it has been started from the 10 AM onwards. So see this video anyhow it would be present after the completion of my session also, but the Dande sir session would not be present after the live classes. That means the video would get deleted. So I would request to each one of you, the person who can understand Hindi definitely should tune to our main channel to have the actual crux or the actual feeling of the control system from the Dande sir. Anyways, come back to the agenda. The agenda behind today's video is very precise and clear. We are going to complete the concept of state space analysis in today's video. Anyways, what we were discussing in the last class. In last class, we saw how the SSA model would look like. SSA model is nothing but the model where we had to deal with the 4 different kinds of the matrix, which is a matrix A, matrix B, matrix C, matrix T. Even I have named them the individual matrix. If you will recall, basically I was dealing with the 2 equations. The first equation was x dot is equals to of ax plus of bu, and similarly y was equals to of cx plus of du. If we will talk about the first equation, it was the state equation, and similarly if we will discuss about the second equation, it was the output equation. See, it is an equation, there is no doubt as such, and you can see very well the focus is on the state variables, and that is why the name has been given as the state equation. And similarly if we will talk about the second equation, it's nothing but the output equation. Why? Because the focus is on output. So may I know the quality of audio as well as video, is it perfect or not? Yes, it's perfect. No? Come here, no issue. Yes. Anyways, come back to this. So basically as far as SSA model is concerned, you had to deal with the 2 different equations. The first equation is going to be state equation, the second equation is going to be output equation. And as I have been communicating in the last class, basically you had to deal with the 4 different kinds of the matrix, matrix A, matrix B, matrix C and matrix T. And I have named them separately. The matrix A is nothing but, it's called system matrix. And similarly, if we'll discuss about the matrix B is nothing but the input matrix. Why it's called the input matrix? You can see very well, this is the factor B which would decide how the x dot is going to be decided by the input. That means how the state variables are going to be affected from the input, and that is why the matrix B is called as input matrix. And now why the matrix A has been said as the system matrix? In future we will see the stability of the system is exclusively defined by the matrix A itself. We will take mod of Si minus A and we will find its root. If all of the roots are being kept towards the left hand side of the j omega plane, then it becomes a stable system. That is why I am exclusively naming matrix A as a system matrix, because the stability of the system would be exclusively defined by the matrix A itself. Agreed? Similarly, if we'll go ahead with the matrix C, you can see very well here y is getting connected with the x. That means output is going to be decided by the different state variables which are present within the system, and hence it's called the output matrix, which we have seen earlier. Output matrix. Yes. And now how the input is affecting your output, and hence it's called feed forward matrix. Anyways, I am not going into the detailed analysis of this feed forward matrix. That means how much forward gain would be offered to the input before getting reciprocated towards the output side. Feed forward matrix. Yes, till this point nobody should have any doubt as such. If you guys would be able to recall, in last class I gave the 2 different RLC circuit and I wanted to calculate its matrix A, B, C or D, or you can say I wanted to convert the given electrical circuit in a form of state space model. If I'll recall, what was the first circuit? The first circuit was a series RLC circuit. If you guys would be able to recall, we had resistance, inductance and capacitance in series. Capacitance in series. Yes. A DC input voltage was used to excite this complete electrical network. Let's take the worth of resistance is R, L and C. The worth of DC voltage is V. Yes. And across the capacitance, the output voltage was observed, measured. Now this electrical circuit has to get converted into form of SSM. This electrical circuit has to be converted in a form of state space model. This is what my agenda. And in 2021 problem have come based on the same concept. Yes, it is one of the important question. And analysis of this problem is very, very important. Very, very important. May I know how many of us could solve this problem? How many of us could solve this problem? If you have solved, well and good. Otherwise, go ahead with my concept. See, whenever you are dealing with any electrical circuit, you should have few ideas before approaching the problem itself. The number of input you have, number of output you have, the number of state variable you have. So at least you'll have a fair idea about the block of SSM, state space model, how many number of input, how many number of state variable, how many number of output you have. So you can see very well, only one input we have, that is nothing but the V, which is exciting the complete circuit. So one input we have. If we'll talk about the output, as such, there is no other electrical parameter has been given at which the output has to be measured. It could have been maybe current across the inductor, it could have been the voltage across the resistance, it could have been the several electrical parameters which has been considered as the output. But as far as this circuit is concerned, I have been focusing over the output voltage alone. So let me do one thing. Let me take a block diagram. First count the number of input. May I know how many number of input we have? Only one input we have. So far the input was referred by a small u, yes, and here the small u is nothing but voltage source V. If we'll talk about the number of output, how many number of output you have? Initially the output was referred by Y, here it is output voltage V0. Similarly, if we'll talk about the number of state variables, which we have seen in the last class, the number of state variables is equals to of effective number of energy storing element is equals to of order of the system. You can see very well, once you will take the Laplace of R, L as well as C, you will get to know the impedance which would be offered by the system. It's in second order. That means the two number of state variables has to be taken into the picture. May I know what are they? The state variable across the inductor would always be the current across the inductor. Why? That we would study as a part of electromagnetic theory. I am not going into the great detail, at least here. And similarly, the voltage across the capacitor. In future, whenever you have to deal with any electrical circuit, one thing should be in your mind, what it is. If you talk about the state variable persisting by the inductor, by default it would be the current possessed by the inductor, and similarly whenever we talk about the state variable across the capacitance, that would be the voltage buffed by the capacitors. That's nothing but the VC. That's nothing but the VC. And here it is state space model. How many number of input you will have? State variables. The two number of state variables you will have. What are they? The first could be IL initially, which was x1. And similarly, the second you can have VC, which was x2. Agree? Yes. And as the electrical network has to be converted in a form of SSM, state space model. So definitely my basic intention is to calculate matrix A, matrix B, matrix C and matrix D. That's it. Yes. May I know what would be the approach? If you'll recall how the matrix A, B, C and D was looking like. See, first you had to take the differentiation of your state variable, and one thing is quite sure, the differentiation of the state variable can be connected with the state variable itself or the input. Yes, this concept must be there in your mind, otherwise you may not be able to proceed with this problem at all. Agreed what I am saying? What I am saying, the derivative of the state variable. The derivative of the state variable should relate with the state variable itself, including the input. And similarly, towards the output equation, the output variable or output node should get connected with the state variable and input. State variable and input. Let me take if any comments you guys are having. Okay. Yes. Okay. So what I am going to do at very beginning, let me focus over the x1 dot. Obviously, once we'll talk about the state equations, may I know what would be the structure of the state equation? It would be a column matrix. The first element is going to be x1 dot, and similarly the second element is going to be x2 dot. What does it mean by the x1 dot? The x1 dot is nothing but the IL dot, and similarly, if we'll talk about the x2 dot, what does it mean by the x2 dot? The x2 dot is nothing but the VC dot. So basically, I would be focusing over the IL dot. Yes. So while solving this problem, my basic focus would be IL dot. IL dot. Anyways, once we discuss about the IL dot, what does that mean of it? That means the differentiation of current across the inductor in time domain, and that is nothing but the DIL by of dt. See, once you will go across the inductor, can you find when the differentiation of the current has been taken place across the inductor and what it used to have the impact? See, you can see very well. The voltage drop across the inductor is being defined as L times of rate of change in current across the inductor, and that is nothing but the LDIL by of dt, and which is nothing but LIL dot. So with the help of this formula, definitely I can bring the outcome DIL by of dt, which is nothing but the IL dot, in terms of x, which is nothing but the IL and VC, and similarly in terms of u, which is nothing but V, which is nothing but V. So may I know how the IL dot can be written in terms of VC, IL, input V? That's a very easy. See how? You can see very well, once you take a complete KVL across this loop, once you take a complete KVL across this loop, definitely if I take the KVL, the minus sign is striking the, or I is striking the minus terminal of V at very beginning. So it's going to be minus of V. And then goes R. How much current is going to flow across the R? That's simply IL. And now here comes L times of DIL by of dt. For the time being, I may write this as IL dot. Yes. And here goes the voltage across the capacitance. See, the voltage across the capacitance can be measured in the two different ways. Either I can write V0, either I can write VC. May I know, should I write VC or should I write V0? I should write VC. Why? Because the IL dot should be written in form of state variables. Obviously, IL is a state variable as well as input. Obviously, V is the input. It should not be written in the form of output. That is why rather writing V0, I would be just writing it VC. I would just be writing it VC is equals to 0. Agreed? And now I would reframe this given differential equation such that I must be able to get the part of A as well as part of B. So what I am going to do over here, see, LIL dot has been kept towards the left hand side and the remaining component has been shifted towards the right hand side. So here it becomes R times of IL plus becomes a minus now. It becomes minus of VC and plus of V. What happens? This L would get shifted towards right hand side. So let me rub this out. So here it becomes minus R by L. Here it becomes minus 1 by L, and simply it becomes V by L. Agreed? So the part of A, B is known up to bit. Now similarly, I need to get the derivative of the second state variable, and that is nothing but the VC dot. So let me focus over the VC dot. Anyways, VC dot is nothing but the differentiation of the voltage across the capacitance in time domain. What does it mean of it? That means it is dVC by of dt. But we know the capacitance time of the rate of change in voltage with respect to the capacitance is nothing but the flow of current across the capacitance itself, which is nothing but IC. But probably you could have figured it out or not, the current across the capacitor is always IL. Why I am writing so? As we have seen earlier, the derivative of the state variable should only be written in terms of maybe state variable itself and the input. So C dVC by dt should not be wrote as IC, simply I would be writing it as IL. Agreed? Till this point nobody should have any doubt as such. Yes. So here goes VC dot is equals to of 1 upon C into IL. Here goes 0 times of VC plus of. There is no straight connection between the VC dot as well as the input. May I know, could you figure it out the value of A and B or not? Yes. May I know how the A and B would be calculated? First focus over the x dot. What would be the x dot? That's going to be x1 dot, that's nothing but the IL dot, and similarly the next is going to be x2 dot, and that is nothing but the VC dot, is equals to, you'll have a matrix A. May I know what would be the order of the matrix, which we have already seen earlier, so nobody should have any doubt as such. So obviously the order is going to be 2 cross 2. Order is going to be 2 cross 2. Now gets multiplied with a column matrix of the variables x1 and x2. May I know what is x1? The x1 is simply IL, and similarly what's x2? X2 is nothing but simply VC. It would have the order of 2 cross 1. It's again 2 cross 1. 2 cross 1, yes. And now it would get added with again a 2 cross 1 matrix, and from where that 2 cross 1 matrix would come? See, I have got only one input, and that is nothing but V, which is in order of 1 cross 1. So by default it has to be order in 2 cross 1. Order in 2 cross 1, yes. So you just had to follow these two equations. This is going to be my first equation, and this is going to be my second equation, and from there easily you would be able to get the matrix A as well as matrix B. May I know what would be the matrix A? See, IL dot is equals to of minus RL divided by of R. So here it's going to be minus R divided by of L. Now IL dot, how it's been connected with the VC? It's been connected with the VC with the multiplier factor of minus 1 by L. So here goes minus 1 by L, agreed? And if you talk about the VC dot, how it is getting connected with the IL? It is getting connected with the IL with a multiplier factor of 1 upon C, obviously 1 upon C. And how the VC dot is getting connected with the VC? No, it's not been connected. It is not been connected. Till this, nobody should have any doubt as such. Now, if we'll talk about how the IL dot is being connected with the V, IL dot is being connected with the V with the multiplier factor of 1 upon L. So simply it's going to be 1 upon L. And if we'll talk about how the VC dot is being connected with the input voltage V, as such there is no dependency. As such there is no dependency. Yes, till this point nobody should have any doubt as such. This goes my matrix A and this goes my matrix B. Matrix B. Yes. So till this point nobody should have any doubt as such. It is a well designed problem, and once you are thorough with this problem, definitely you would be able to smash any sort of the electrical circuit, and you would be able to convert that electrical circuit into its SSM, state space model. Till this point nobody should have any doubt as such. Yes. And now if we'll talk about the matrix C as well as matrix D, the matrix C as well as the matrix D are the part of the output matrix. The output variables has to get connected with the state variable as well as input itself. You can see very well the output is very same as VC. Can I write V naught in terms of VC? Obviously sir, the output can be written in terms of state variable as well as the input. So obviously I can write that. So simply if I would be taking the next page, here comes the output. V naught is simply equals to of VC. So let me focus over the matrix C as well as matrix D. May I know what would be the order of matrix C and D? Anyways, start with the complete matrix itself. The output, it has to be a column matrix, but only one number of output we have got it so far. So it's gonna be number of output, that's a 1. Being a column matrix, it's gonna be 1 cross 1. It's gonna be 1 cross 1. Yes, and here goes matrix C. It has to get converted, or it has to get multiplied with X. What does that mean by the X? The X is nothing but a state variable. Being a column matrix, the first data is gonna be IL and second data is gonna be VC. Nobody should interchange this. At very starting, the X1 has been taken as IL and X2 has been taken as V2. So in future, you should not change that. It has to have the same sequence. Agreed? May I know how the V naught is being connected with the IL? No sir, it is not at all connected. And how the V naught is being connected with the VC? The V naught and VC is very same. And even the voltage across the capacitance is deciding the output voltage. So simply it's been becoming 0 and 1. 0 and 1. End of the day, now I would be watching how the output voltage is getting connected with the input voltage. If it is 1 cross 1, even the input, how many number of input we have got it? Only one input we have got it, and that's nothing but the 1 cross 1, and hence the matrix D should also be 1 cross 1 in order. Agreed? May I know the output, whether it's getting connected with the input? No, the output is simply equals to of VC, which is type of a state variable. So obviously it becomes 0. It becomes 0. So now that is what I am saying. They may ask you to get the value of A, B and C. Matrix A which we have already calculated, matrix B, which we have already calculated, and similarly matrix C, which we have already calculated, and matrix D, which we have already calculated. Yes. If you want, I can recall them out. So where was the matrix A? This was the matrix A, minus R by L minus 1 by L, minus R by L minus 1 by L, 1 by L, probably it was 1 upon C and it was 0. If we'll talk about the matrix B, it's gonna be 0, 1, and similarly if we'll talk about the matrix D, it's simply a null matrix 1 cross 1, and if we'll talk about this, it's gonna be 1 upon L, 1 upon L. Just a minute, here it is B, B, here it is C, here it is 1 upon L, 1 upon L, and here it's gonna be 0, here it's gonna be 0. Till this point, nobody should have any doubt as such. Yes, if it is clear, just write clear somewhere. And I do not know whether you have remembered it or not. As I have been telling you guys, the matrix A, B, C, and D, obviously it's gonna be the matrix, but the component within the matrix are supposed to be the real number. You can see very well, R would be in ohms, L would be in henries, similarly capacitance would be in farads. If the values of R, L, and C are fixed values, they just would be a real coefficients, real coefficients. Yes. Till this point, nobody should have any doubt as such. If it is clear, just write clear somewhere. Let me go ahead with the next question. Let me go ahead with the next question. The second electrical circuit which was given in last class, and now also I had to convert that given electrical circuit into its equivalent SSM model or state space model. So the circuit, if you would be able to recall the circuit which I have taken or which I have given as the homework, the source was a current source. In parallel with the current source, we had a capacitance, we had the inductance, and the output voltage was taken across the load resistance or resistive load R. Here comes V0, here comes V0. Yes, till this point nobody should have any doubt as such. Nobody is replying no issue. Yes. See, what is happening over here? Whenever the electrical circuit has to be converted into form of electrical circuit has to get converted in a form of its state space model. We start with a block diagram. May I know what does it mean by the block diagram? At least I should have the clear-cut number of input, state variables as well as output we have for the given electrical circuit. Yes. So what I would do, let me take a block which is state space model. How many number of physical input we have? You can see very well, only one input we have which has been exciting the complete circuit. Yes, and that is nothing but I. And so far the input was written in terms of U, so you can write U or I in terms of U. Yes. And if we'll talk about the number of state variables you have, how many number of state variables you'll have? You can see very well, if we'll talk about the order of the system would be 2 because of the presence of the capacitance as well as inductance. So the 2 number of state variables you'll have. Usually the state variables were written in terms of x1 and x2. The first state variable would be the voltage across the capacitance and similarly current across the inductor. And even alternatively you can change x1 as the current across the inductor and similarly x2 as the voltage across the capacitor. Choice is yours. Choice is yours. But in the last problem I have taken the x1 as I of L, x2 as V of C, so deliberately I am changing the sequence of it. What I have done, I have taken the voltage across the capacitance as the first state variable, so here goes V of C. And similarly the current across the inductor as the second state variable, I have taken here over I of L. And how many number of output we have? Although we have got the several number of branches through which the current can be observed, I have got the several number of nodes at which the voltage can be observed, but as far as this problem is concerned, they have just asked to focus over the voltage across the R, which is nothing but the output voltage. Keep in mind, the output was referred by Y, and that is nothing but the V0. That is nothing but V0. Nobody should have any doubt as such till this point. Agreed? See why I am doing so, at least I have got to know the number of input branches we have, only 1. The number of state variables we have, that's precisely 2. The number of outputs we have, just one. Agreed? May I know what are the different equations are involved with the SSM? The 2 different equations are involved. Either you can rewrite, either you can recall. What it was, the x1 dot is equals to of ax plus of bu, and similarly y is equals to of Cx plus of du. The first was a state equation, the second was the output equation. So just focus over the first equation. May I know what would be the datas of x dot? The x dot is going to be x1 dot as well as x2 dot. What does it mean by the x1 dot? The x1 dot is nothing but the Vc dot, and similarly what does it mean by the x2 dot? The x2 dot is nothing but the IL dot. So rather writing the equation again and again, just focus what would be the worth of Vc dot as well as IL dot. But that worth has to be rewritten in terms of, you can see very well, x dot is equals to ax plus bu. That means the derivative of the state variable has to be written in terms of the state variable or the input. Yes. So I would be writing the derivative of the Vc dot in terms of IL, Vc, I. Similarly, the derivative of IL dot in terms of Vc, IL and I. Agreed? Nobody should have any doubt as such. So whatever the KVL, whatever the KCL, whatever the law you had to apply within the circuit, that has to move around the same concept, that the Vc dot should be the function of Vc IL I. Similarly, IL dot has to be the function of Vc IL and I. And from there you would be able to get the equation number 1, and from there you would be able to extract the matrix A, matrix B. Yes, and end of the day, if the output gets connected with the state variable as well as input, you would be able to get the matrix C as well as matrix D. Nobody should have any doubt as such. Let me focus over the first. So here goes Vc dot. Vc dot. See, anyways, my agenda is to calculate the Vc dot, and it has to be the function of, what? Vc, IL and V. That's it. And then I would be focusing over the IL dot, and again that has to be the function of Vc, IL and V. What does that mean by the Vc dot? How electrically Vc dot can come into the picture? See, C times of dVc by of dt, C times of rate of change in voltage across the capacitance decides the current across the capacitance. Anyways, from where this equation comes out? This equation comes out after taking a long process of Faraday's conclusion. Anyways, I am not going into that detail. Yes. But yes, the current across the capacitance would be useful to get the Vc dot, So now here goes the next calculation. See, first focus over the Vc. What does that mean by the Vc? The Vc is nothing but the state variable, which is nothing but the voltage across the capacitance. So here comes Vc. Similarly, the second variable, which is nothing but the x2, for this electrical circuit it's IL, and IL is nothing but the current across the inductor, and here comes IL. Here comes the IL. Agreed? For the calculation of the Vc dot, I would start from C dVc by dt, and simply we can write C Vc dot. What does it mean of it? That's nothing but the current across the capacitor. For the time being, the current across the capacitor is being taken as I of C. Agreed? Till this point, nobody should have any doubt as such. But I am not free to write C Vc dot in terms of IC. I should write in terms of Vc, IL and V. That's possible. See how? See. The current of I is coming in to this node. The current IC is leaving from this node, and similarly current IL is leaving from this node. So at least at this node you can apply the KCL, and what it is? The capital I is bifurcated into two parts. First is nothing but the current across the capacitor, that is nothing but C dVc by of dt, which is nothing but C Vc dot. Agreed? And the second part of the current has gone through the inductor, and which is nothing but the IL dot. That's more than adequate to rewrite the Vc dot in terms of Vc, IL and V. You can write by yourself. See, so here it becomes C Vc dot is equals to of 0 times of Vc plus of, not plus, exactly it's a minus of IL plus of capital I. Yes. So C dVc by dt has been kept towards left hand side. The remaining component has been shifted. So first goes minus of IL, and thereafter the I remains as it is. If you guys are having any sort of doubt, you can ask. No, it won't be the last class. Probably 2 more classes or 1 more class would be required. Agreed till this point? So here is going to be I is equals to of C Vc dot plus of IL. Anyways, let me rearrange this. So here goes a Vc dot is equals to 0 times of Vc minus 1 divided by of C times of IL, and here goes I divided by of C. So at least the first important equation have come into the picture, which would decide the part of A as well as part of B. The complete A and B has not been decided yet, yes, but I would be discussing over the derivative of the next state variable, and that's nothing but the IL dot. That's nothing but the IL dot. What does it mean by the IL dot? Anyways, the IL dot can be calculated in terms of the voltage across the inductor is being defined as LIL dot. LIL dot. Agreed? LIL dot. The voltage across the inductor. But now, as we have seen, the VC dot can be written in terms of VC, IL and V. Now the even IL dot should be written in terms of the inputs as well as the state variables, which are nothing but VC, IL and V. May I know what would be the approach you will have? See, you can see very well. You can apply a KVL across this loop. Yes. Any current flows through this loop, it is striking the minus polarity of VC. So obviously it becomes minus of VC. Then it strikes the voltage across the inductor, which is nothing but L DIL by of dt. That is nothing but the L IL dot, and then it goes R times of IL is equals to 0. So whatever the value we wanted to calculate in terms of IL, VC, each and everything have come into the picture. Yes, tell me what would be the result out of this. So here goes LIL dot is equals to of plus VC, yes, minus of R times of IL, yes, plus of 0. So if I would like to write the IL dot, so the IL dot is simply going to be 1 upon of L into VC. Similarly, here goes minus R divided by of L into IL, and here goes 0. And this would be the second important equation, which would be useful while calculation of matrix A as well as matrix B. Yes. If you would be able to recall, for the given electrical system, what would be the X dot? The X dot would be X1 dot as well as X2 dot. What does it mean by the X1 dot? Is simply equals to of VC dot. And similarly, here it's gonna be IL dot. Yes, it's a 2 cross 1. Now you will have a matrix A. May I know what would be the order of the matrix A? The order of the matrix A would be 2 cross 2. Always it used to be a square matrix, which we have seen in the last class. Yes. And now even the derivative of the state variables has to get connected with the state variable itself. Here comes VC, here comes IL. Yes, may I know the VC dot, how it's been connected with the VC? The VC dot is no, it's not been connected with the VC. That means the effect of VC over the VC dot is absent. And similarly, the effect of IL over the VC dot is nothing but minus 1 upon C. Similarly, go with the IL dot. The IL dot is getting connected with the VC. Is nothing but the 1 upon L. Here goes minus R divided by L. How many number of inputs we have? You can see very well, only one number of input we had. So obviously the matrix U would be 1 cross 1, where the U is nothing but I itself. So here comes I within order of 1 cross 1. So may I know what would be the structure of matrix B? It would be in order of 2 cross 1. Yes. If we'll talk about the VC dot, whether it's getting connected with the I, yes sir, it's getting connected with the I, and that is nothing but 1 upon C. And similarly, IL dot, whether it's getting connected with I, no sir, it's not getting connected. Yes, so till this point, nobody should have any doubt as such. Here goes the matrix A, here comes the matrix B. Now, if I will focus over the matrix C as well as matrix D, that also can be easily calculated. Now, that calculation has to be taken place in your brain. May I know what would be the matrix C as well as matrix D? First, focus over the output matrix itself. The output matrix, towards the leftmost side, you will have a matrix of Y. How many number of variables you will have? Being a column matrix, only one variable you will have, and that's nothing but the output. Instead, the Y, it's simply going to be V0. Now that V0 has to get connected with the different state variables. Keep in mind, if the sequence has been taken with VC then IL, the same sequence has to be followed over here. Here becomes VC and IL. Yes, the order of this matrix would be 2 cross 1, and the order of this matrix has to be 1 cross 2 to match their multiplication as 1 cross 1. To match their multiplication as 1 cross 1. Agreed? May I know what would be the output? You can see very well the output voltage V0 can be easily connected with the state variable. The current across the inductor and the current across the resistor would be same as they are in series. So IL times of R is going to decide my V0. So simply VC independent, and here it's gonna be just R times of IL. R times of IL. And if I'll talk about how the input is going to be affecting the output, no. First the input has decided the value of IL. Now the IL is going to decide the value of V0. Nobody should say the input is not deciding my output. See, the input has decided the different variables. The different variables have decided the derivative of the different variables, and end of the day, the input as well as state variables together is going to decide my output. Here goes matrix C, here comes the matrix D, here comes the matrix A, here comes the matrix B. Agree? And in last class, I was discussing about the order of the matrix A, B, C, and D. Even you can cross check the order of the matrix A. What used to be the order of the matrix A? That's nothing but the number of state variable into number of state variable. You can see very well how many number of state variables we had. We had the 2 number of state variable. It used to be a square matrix. Similarly, if we'll talk about the matrix B, what used to be the matrix B? Matrix B. Again, you can check each and everything which was communicated in the last class. I do not have that much time such that I would go into the great detail of the order of the each and individual matrix. Now the one thing comes in a mind, sir, such a big derivation we have taken, but what was the advantage of this derivation? My dear friends, this complete electrical circuit has been converted in a form of mathematics. The 4 different matrices we have got, the matrix A, matrix B, matrix C, matrix D. So in future, we can completely replace this electrical circuit with the matrix, and now that matrix can be fed into your computer system. The analog signal, whatever it comes in, first I would convert into analog to digital form. It would be processed with this 4 different matrix. Again, the digital output would go towards output side. It has to get converted in a form of analog signal. What has happened? The complete signal has got processed with this electrical circuit itself. Agreed? What does that mean? That means you did not design this electrical circuit, you did not purchase R, L and C, but still these 4 equations are sufficing the requirement, and the requirement became so simple to design. You can design with any of the controller, any of the computer based system. Till this point, nobody should have any doubt as such. Agree? Yes. Now I have seen in the few papers what they used to do. They would be giving the transfer function, and they wanted to convert the given transfer function into form of the state space model. Keep in mind, at any moment of time, the given transfer function can be converted in a form of its equivalent state space model. The state space model have got one advantage, that it can consider the initial conditions also. But if the transfer function is getting converted in a form of state space model, obviously the same fundamental has to be kept in our mind, that all of the initial conditions were dropped. But yet, yes, at any moment of time, any of the given transfer function can be converted in a form of SSM, state space model. That means the given transfer function can be converted in a form of mathematical matrix A, B, C and D. That's it. Agreed? So let me focus over the conversion. And I have seen the problem comes from this zone. Is the conversion. Yes, what does it mean by the conversion? That means we would have a transfer function. Yes, which would be the function of S. And designing the transfer function is a very tedious task. For designing any given transfer function, you have to purchase the R, L and C from the market. As we have seen in the last class, the availability of R, L and C in the market is not that great. That's the first problem. And even with the respect to the temperature, even the values of R, L and C also changes. So definitely, the T of S would be in great danger with respect to the environmental changes. What I am going to do, now this transfer function has to get converted in a form of SSM. That means this complete transfer function would get converted into the matrix form of mathematics, which is matrix A, matrix B, matrix C and matrix D. Although the state space model can accept the initial condition, but as the transfer function have got converted in a form of SSM, so by default I have left all of the initial conditions. So in future I would be taking the reference of what is it? The state variables. State variable at t is equals to 0 is being taken as 0. is being taken as 0. Agreed? The three different methodologies we use, and all of three methodologies are effective in different cases. The first method is called canonical form. Canonical form, where I would be using the block diagram approach to resolve the given transfer function into the form of SSM. The second is going to be differential equation form. Last, never the least, the last method is called SFG, signal flow graph. Usually the canonical form is more useful when the poles of the transfer functions are pure real. Similarly, the SFG, the technique of SFG is more useful when the poles contained by the given transfer function are in a form of maybe complex conjugate. Once we'll be having few number of numericals, the things would be even clear. Yes. Till this point, nobody should have any doubt as such. Let me go forward. Let me take first problem. I have taken a transfer function T of S. For the sake of simplicity, I have taken the first order transfer function 1 divided by S plus 1. I wanted to convert this given transfer function in a form of SSM. Anyways, I would be using the canonical form. You can see very well, you have got only one pole and that has been kept at -1, pure real. So the approach which we use, first I convert the given transfer function into the standard negative feedback system. How it's possible? It's quite easy. What I would do, I would take S common from the denominator. So the factor which would be left out, you can do one thing, you can change it to 2. So here it becomes 1 plus 2 divided by of S. And once you'll compare this given transfer function into the standard form of the negative feedback, definitely you'll get to know the G as well as H is known to me. Yes, G as well as H is known to me. G is nothing but 1 upon S, and similarly H is nothing but 2. The feedback element is 2, and similarly feed forward element is 1 upon S. Yes. No issue. Anyways, what I am saying, my lecture would be available even after completion of my video itself. But Dandesh sir video would not be available once his complete session or the complete marathon would get over. So do one thing, just focus over the Dandesh sir class. And then after completing the Dandesh sir class, you can come back to my video. Definitely, you should do that. Even I have communicated the same thing at very beginning of my video. Yes, so here it becomes Gs is equals to 1 upon S, H is equals to 2. So while designing the standard negative feedback system, you can see very well the G is nothing but 1 upon S, which is an integration in time domain, that's fine. And similarly, the feedback element has the gain of 2, Yes. The output used to be written in terms of C. Similarly, the input is being written as in terms of U. But rather writing it in terms of C, rather writing in terms of U, I would be writing this as Y of S. Why? Because at least in SSM, the output was referred as a small y, and similarly, the input was referred as a small u. So I may write this as U of S. I may write this as Y of S. Agreed? Till this point, nobody should have any doubt as such. Now, what I would do, see, I have written the variable worth at this point as x1 dot. See why I have written so? So in future, if the x1 dot, that's nothing but the derivative of the state variable x1 gets processed with 1 upon S, what does that mean of it? It's the integration in time domain. So differentiation in time domain gets processed with the integration in time domain would become x now, x1. Anyways, for this problem, how many number of state variables are required? That would be easily known from the number of poles the transfer function is carrying. How many number of poles are carried by the transfer function? Only one number of pole is carried by the transfer function. So obviously only one state variable would be used, and that's nothing but the x1. End of the day, what we had to do? We had to derive matrix A, B, matrix C, D. Matrix A and B would be derived from the state equation, which used to be x dot is equals to of Ax plus Bu, and similarly the output would be derived from the output equation, which is nothing but the y is equals to Cx plus of du. Yes. So let me do one thing. X1 dot. We have seen in case of signal flow graph, the variable worth is just being decided by its incomer. May I know at this node what are the incomers we have? The first incomer is coming in terms of u of s, and the second incomer is coming in terms of 2 times of y of s. And as we are writing in time domain, I have seen many of the times the student used to do mistake. Here I am writing each and everything in the time domain. Why? Because here the x1 dot is nothing but the differentiation of the state variable in time domain, dx1 divided by dt. Yes. Yes, 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 yes. So here it becomes, I would be writing x1, that is just getting multiplied with 2. And may I know the input, how much input we have? The input has straight away been fed in. So here it's going to be 1 times of, either you can write u of t or simply you can write 1 of u. And similarly, if we talk about the output, again the output should also be written in the time domain. Nobody should have any confusion as such. What is the output? The output has to get connected with the input as well as the state variable. You can see very well, if here the state variable is x1, may I know what would be the state variable over here? See, the worth of the state variable would be just decided by its incomer, and you can see very well the incomer to this node is only coming from this branch, and the worth of this state variable is x1 and the gain is simply 1. So the y is simply equals to of x1, simply equals to of x1. Agreed? Now if we'll talk about the A is gonna be a 1 cross 1 matrix with the element of 2. And similarly, if we'll talk about B, again it's gonna be a 1 cross 1 matrix with the element of 1. And similarly, if we'll talk about the matrix C, here it's a 1 cross 1 again with the element of 1. And if we'll talk about the D, it's gonna be a null matrix. Null matrix. Nobody should have any doubt as such. Agreed? It's a canonical form. It's a canonical form. Yes? Now what I would do, I would go into the next slide. And let me take the next problem. See, the number of poles which we had earlier is only 1. So let me increase the number of poles a transfer function carries. So I have taken an example of the different system T of S, which is equals to of S square plus of 3 of s plus of 2. Anyways, before converting the given transfer function in the form of SSM, should I know whether the poles located with the transfer functions are real or not? If it is real, definitely I can go ahead with the canonical form. You can see very well 1 upon s square plus of 3s plus 2 can be written in the factors of s plus 1 into s plus 2. Yes. So obviously both of the roots are real. That's more than adequate to smash this problem with the help of canonical form. So what we do, the same process I would be using as I have been using so far. I would be taking the reference of the given transfer function, the two factors we had at denominator, which is nothing but s plus 1 and s plus 2. What I would do, I would take its partial fraction. Anyways, we would be getting the real values of A as well as B, positive and negative depending on the different problems. Yes. But again, I would be using the same fundamental. I would be converting the first system into the standard form of the negative feedback, and the second system in a form of a standard negative feedback. So what would be the approach? Anyways, 1 upon s plus 1 into s plus 2 was output. Output was y in Laplace domain y of s. Input was u in Laplace domain. It was u of s. Agreed? And once you will shift the u of s towards the input side, that means the y of s is going to be decided by the two factor. What are those? A divided by of s plus 1, which would be processing u of s, and similarly b divided by of s plus 1, which would be processing u of s. Anyways, it's s plus 2, no? It's s plus 2. Yes, s plus 2. Agreed? Till this point, nobody should have any doubt as such. So what I would be doing? I would be just focusing over this factor. So here it becomes A. I would be converting into the standard negative feedback. So here it goes, yes, which we have seen earlier. Here goes B. What I would be doing? I would be taking S common from the denominator. So the factor which was been left out at the numerator is going to be 1 upon S. And here it becomes 1 plus 2 divided by of S. 2 divided by of S. For the time being, I may write y of S. Now this factor gets multiplied with u of s. That means the u of s has to get processed with A into 1 upon s divided by 1 plus s. Similarly, B into 1 upon s divided by 1 plus 2s. And the addition of both of the processed output would decide your y of s. Agreed? So y of s would have the two different branches, and the sum of these two different branches would become y of s. The first would come from here, the second would come from here. Agreed? So let me do one thing. Let me draw how the system would look like. Where should I draw it? I can draw over here itself. Yes, here goes the input u of s. Here goes the input u of s. Yes, here goes the input u of s. The u of s has to be processed by the two different structures. The first is this, the second is this. Let me draw this first. You will have 1 upon s first. Just a minute. Here comes 1 upon s. 1 upon s. The feedback element is 1. The type of feedback is negative. And the input which is coming to the summer circuit is nothing but the u of s itself. Yes, the first part is over. Now I would be focusing over the second part. The second part is also more or less same. And here comes, yes, and here it becomes minus, minus. Yes, now before the signal gets added, it requires the additional gain of A with first and similarly the additional gain of B with second. So what I would be doing? After getting processed with 1 upon s divided by 1 plus 1 upon s, I would be providing the additional gain of A and similarly I would be providing the additional gain of B. Additional gain of B. Yes, they would get added and here it would y. Here it would be y. Yes, till this point nobody should have any doubt as such. Till this point nobody should have any doubt as such. Agreed? Now again the next thing comes in mind, how many number of variables we are going to choose to smash this problem in terms of SSM, the two number of variables we are going to choose. Why? The number of the poles which are involved with the system is nothing but the 2, order of the system is nothing but 2, that's more than adequate to indicate the number of state variables which we will be choosing is nothing but 2. Now the same process I would be using, see 1 upon s is already there, that means it's going to integrate in the time domain, so why don't we take here x1 dot, why we need to take x1 dot? Once you'll see the state equation, the x1 dot has to get connected in terms of x as well as input. That is why the x1 dot has been taken. Now the next thing comes in your mind, should I take x1 dot over here or should I take the x1 dot over here? If it is x1 dot by default it would be x2 dot, if it is x1 dot by default it would be x2 dot, it's completely your choice. And that is why we say state space model is not a unique model. What I am saying, state space model is not a unique model. What does that mean of it? That means if one person have taken this as x1 dot and this as x2 dot, the second person have taken this as x2 dot and this as x1 dot, they would have the different structure of A, B, C and D. But one of the most important thing, although they might be looking different, but the information contained by A, B, C and D is unique. If you want to write somewhere, you can write the state space model A, B, C, D. They are matrix. They are not unique. They are not unique. That means within the given system, if you choose the different locations of x1 dot, x2 dot, x1 and x2, definitely the structure of the matrix is supposed to change. But the unique information what they contain, no, they are not going to change. They are not going to change. Agreed? Till this point nobody should have any doubt as such. So the choice is yours, as I have said. Here it will be x1 dot. Let's take here it is x2 dot. You can see very well the x1 dot, that's nothing but the differentiation of the variable x1 in time domain gets processed with the 1 upon s, that's the integration in time domain. Here it would become x1, here it would become x1. Yes, similarly it's a x2. May I know the worth across this takeoff point, would it be x2 and x1? Yes, obviously, because only one incomer is coming to this takeoff point and hence it's simply going to be x1 and simply going to be x2, simply going to be x2. Now what I would do the same process which I have been doing. The derivative of the state variable has to be written in terms of the state variable as well as the input itself. So why don't we start with the x1 dot? May I know how the x1 dot is looking like? X1 dot has to be written in terms of a constant multiplier with x1 plus constant multiplier with the x2 plus constant multiplier with the input. Similarly, the x2 dot has to be written in terms of constant multiplier of x1 plus of constant multiplier of x2 plus of constant multiplier of the input, which is nothing but u. You can see very well. What is x1 dot? The x1 dot have got the two inputs. From where? The first input have straight away gone from the input itself, which is nothing but the US, and the second input have come from the x1. How much gain you have offered before feeding into the summing circuit? That's nothing but the -1. So the x1 dot is simply equals to of minus x1, and you can see very well it's quite independent from the x2. The x2 is kept somewhere here, and the x1 dot is not going to be affected from the x2 dot. Yes. And here comes the input. Obviously, sir, the input is affecting with the gain of 1. Here comes u. Small u would be the better representation, because I am writing each and everything in the time domain, and here each and everything was in Laplace domain. This one, although this was in time domain, this was in time domain. Agreed? Now, similarly, let me move ahead with the x2 dot. May I know what would be the exact structure of this? What would be the exact structure of this? Here becomes 0. Here it becomes -2 times of x2, and here it becomes 1 times of u. 1 times of u. So the pain of A and B is gone. You know the matrix A as well as matrix B, where the matrix A is called the system matrix and matrix B is called the input matrix. Input matrix. Yes. Now let me focus over the output matrix. This was a state equation. And from the state equation, easily you would be able to figure it out, the value of A, that is nothing but the system matrix, matrix B, which is nothing but the input matrix. Let me focus over the output matrix. How the output is getting connected with the state variables as well as input. You can see very well, the node worth was x1, the x1 is getting gain of A and then getting processed towards Y, and similarly now the x2 is getting B, getting gain of B and getting processed towards Y. What does it mean of it? Simply the Y can be written as A times of x1 plus of B times of x2. That's it. And here goes your output equation, and you can see very well the output equations is completely bakeover from the input. Now it's turn to write A. May I know what would be the matrix A? Simply it would be -1, 0, 0, -2. 0, 0, -2. Similarly, if we'll talk about the matrix B, just a minute. Here goes the matrix B, here comes the matrix A. May I know what would be the matrix B? Here comes 1 and 1. Here comes 1 and 1. Yes. If we'll talk about the matrix C, the matrix C is gonna be a row matrix, which we have seen earlier. Here comes the multiplier factors A and B. And end of the day, D is simply gonna be a null matrix with an order of 0, 0 or 1, 1. Agreed? If till this point each and everything is clear, just write clear, so at least I'll have a idea that yes, you people could understand something. Yes. So this would be the lump sum idea how to deal with the problem where the transfer function is given and I had to convert the given transfer function in the terms of SSM. Yes, SSM. Tell me each and everything is clear. So at least one comment I want so that I can proceed further. Tell me till this point each and everything is clear or not. Clear, no? Okay, then it's fine. So let me focus over the next problem. Probably I have designed somewhere. Okay, leave aside for the time being. If I have taken a transfer function T of S, yes, T of S. Let's take, the structure is sort of S plus 2 divided by of S square plus of 2S plus 2. And we wanted to convert the given transfer function into the form of state space model. May I know what would be your approach? You can see very well, once we would be focusing over the poles of the given transfer function, you will get to know their poles are located at -1 plus -j. That means definitely I cannot segregate their poles and I cannot do the analysis in terms of canonical form. So what would be your next approach? My next approach would be SFG approach. What it is? SFG approach. Although separately I am not teaching how the SFG approach would be applicable, but with the help of this problem we are going to learn each and everything. You need not to have any worry about it. See what I am going to do. I would convert the given transfer function into the standard form of the Mason's gain formula. May I know what was the Mason's gain formula? Towards the numerator we had P1 del 1 plus P2 del 2 plus of P3 del 3, so on and so forth. And at denominator we had del. What was the del? It was 1 minus the discrete sum of the individual loops plus of the discrete sum of the two non-touching loops, so on and so forth. What I have done deliberately, I have simplified the Mason's gain formula MGF as P1, P2, so on and so forth divided by of 1 minus of loop 1, loop 2, so on and so forth. Can you tell me how and when this simplification is valid? This simplification is valid only and only if the del 1, del 2, del 3, they all are 1. When the del 1, del 2 and del 3, they all are 1, that means whenever you draw a path 1 and all of the branches or all of the nodes which has been used while drawing P1, that smashes all of the loops. Could you agree what I am saying? That means in future, if we'll just focus over the P1, you will see the different nodes which has been used while drawing the P1. If those nodes are rubbed out, you have not been left out with any of the loop, such that the value of del 1 would not be equals to 1, would not be equals to 1. Yes, till this point nobody should have any doubt. And similarly it goes with the P2. Although I cannot write each and every statement which comes along the method of SFG, but at least you should have those things in your mind. Yes. And similarly, you can see very well the 2 non-touching, 3 non-touching, the concept of the non-touching loop should not be there within your system itself. So I can say one thing, del 1, del 2, del 3, they all must be 1. What does that mean of it? Whenever we draw the path, I should touch all of the nodes which are used while drawing the loop. That's the first thing. That's the first thing. If we'll talk about the second one, the concept of non-touching loops. The concept of non-touching loop is not there, is absent. That means all of the loops are touching. All of the loops are touching. Taking the reference of this concept, we would move forward. We would move forward. Agreed? Yes. How we will move forward? See, try to understand this. So again, I would recall what was my transfer function. For the time being, it is nothing but T of S. Agreed? S plus 2 divided by of S square plus of 2S plus of 2. What I used to do, I used to take the highest degree of S from the numerator as well as denominator. Yes. So here it becomes simply the S square has been taken common from the denominator. So the factor which has been left out at numerator is going to be S divided by of S square, which is simply equals to 1 upon S. And similarly 2 divided by S square is simply equals to of 2 divided by S square. Agreed? Now at denominator it becomes 1 plus of 2 divided by of S plus of 2 divided by of S square. Yes. I can rearrange this transfer function into the standard Mason's gain formula where I do not have any touching loops, whereas the values of del 1, del 2, they all are 1. See how it's possible. Let me rearrange this complete transfer function. Let it be 1 upon S as 1 upon S, 2 upon S square as 2 upon S square. At denominator, what change I am proposing? Why don't we write this as 1 minus y? In case of del, when we do not have any touching loops, non-touching loops, so we used to have the formula like 1 minus of individual loop gain. So obviously the first loop gain is minus 2s and the second loop gain is again minus 2 of s square, minus of 2 of s square. So let me draw the equivalent SFG which satisfies this transfer function, and from there we will try to get the matrix A, B, C and D, and which would convert the given transfer function into the equivalent form of. Yes. So here goes the SFG. See, you can see very well we have been allocated with the two path. The first path would have the gain as 1 upon s and the second path would have the gain of 2 of f square. So what I have done, deliberately I have chosen the 3 nodes, and in individual nodes the path gain is being taken as, or the transmittance is being taken as 1 upon s. So you can see very well, in between this node to this node the gain is 1 upon s, in between this node to this node is 1 upon s square. So in future what I would do, I would take a additional branch and would be connecting to the output, taking the gain of 1 obviously, which is going to decide your output. Now secondly, to simulate or to accommodate this part, what I would do, I would take another path taking the gain of 2, which would decide the output, Agreed? Till this point nobody should have any doubt as such. Now if we'll talk about the individual loops, we had the individual loops. Obviously we had the individual loop. You can have the first loop whose gain is minus 2 divided by of s. So obviously this feedback path gain has to be minus 2. Yes, and the next is minus 2 divided by f s square. You can take this as minus 2 divided by f s square. Minus 2 divided by f s square. Even you can shift this loop to this side. Still, there would not be any problem as such. There would not be any problem as such. Now here comes my input. The input in Laplace domain was written as u of s with the gain of 1. And similarly, how the output is being decided? The output has to be being decided. Let's take here the output y of s. For safety, what I have done, I have taken a dummy node, and here the gain is 1. Here the gain is 1. Yes. Now focus over the forward path. The first forward path gain has to be 1 upon s. What does that mean of it? You can see very well. The first forward path gain is 1 upon s. So obviously, the transmittance at this branch has to be 1. You can see very well. Zoom. That's nothing but 1 into 1 upon s into 1. That's nothing but the 1 upon s itself. The second has to be 2 divided by s square. So obviously, we had to use both of the branches, because first would provide 1 upon s, the second would provide 1 upon s. 1 upon s would get multiplied with the 1 upon s, would become 1 upon s square, and now the additional gain of 2 has to be offered. 2 has to be offered. Yes, till this point nobody should have any doubt as such. And as far as the order of the system is concerned, it's a second order system. So definitely we are going to take the 2 number of state variables for this given problem. So what I have done, deliberately I have taken the worth of this variable or this node is nothing but x naught, and similarly here it is x2 dot. Keep in mind they are in time domain. The rest of the calculation you can do by yourself. Tell me x1 dot, what are the different inputs are supposed to come? The first input is coming from the u of s itself. The second input is coming from x2 dot itself. The third input is coming from this node itself. Anyways, you can see, just a minute. Yes. Now I can simplify this problem a bit more. May I know what would be the x2 dot? The variable across this node would just be defined by its incomer. The incomer which is coming to this node is only coming from x1 dot. You can see very well, x1 dot. That means the x1 dot is getting processed with 1 upon s. Obviously, there would be the integration in time domain. So the x2 dot is precisely x1 in this problem. Similarly, if we'll talk about the variable worth at this point, you'll get to know this is x2 dot. The x2 dot had the process of integration through this branch, and now it became just x2. Why? Because the incomer across this node was only 1, and which was coming from this path. So obviously it becomes x2. Till this point nobody should have any doubt as such. Now it becomes much easy to dictate the x1 dot in terms of x1, x2 and u, and similarly x2 dot in terms of x1, x2 and u. Nobody should write x1 dot in terms of x2 dot or x2 dot in terms of x1 dot or x2 dot. That's not permissible. If we'll talk about the first equation, which used to be the state equation, the derivative of the state variable has to be dependent over the state variables itself or the inputs, or including both. That is why a little bit changes has been accommodated. Agreed? So let me focus over the first one. The node worth at the first node would be decided by its incomer. May I know from where the incomers are coming? The first incomer is coming from x1 itself with the worth of the gain minus of 2. The second one is coming from x2 with the gain of minus 2. Agreed? With the gain of minus 2. Till this point nobody should have any doubt as such. Now the next input, yes sir, input is also coming with the gain of just 1. In time domain, I may write this as u itself. Similarly, if we'll talk about the x2 dot, this is nothing but the x2 dot. How many number of incomers we have? Only one incomer. Even the x2 dot was prejudged as x1. So here goes 1 times of x1, 0 times of x2, plus of 0 times of u. Why I am writing in terms of 0 and 0? Because anyhow the x2 dot has to show its dependency over the x2, x1 as well as u once I would be formatting a, b and c and d. A, B, C and D. Agreed till this point? So obviously, end of the day, you may also be interested in finding the output. May I know from where the output has been picked out? See, the output node have been coming, or the incomer to the output node have been coming from this node. The gain is 1, that means the worth across this node and the worth across this node is very same. And you can see very well the incomer to this node have been coming from the two different branches, from first branch and from the second branch. The first branch is the branch of x1, and the x1 is getting gain of 1, and similarly the second node is nothing but the x2, and which held the gain of 2. So here it becomes x1 plus of 2 times of x2, x1 plus of 2 times of x2. So easily you would be able to get the value of A. May I know what would be the value of A? The A is gonna be minus 2, 1 and 0. That's gonna be your matrix A. Yes, till this point nobody should have any doubt as such. If we'll talk about the matrix B, the matrix B is gonna be 1 and 0. Yes, here also there is no problem as such. If we'll talk about the matrix C, it would be a row matrix. It is 1 and 2, and if we'll talk about the matrix D, it's simply gonna be 0. It's simply gonna be 0. Yes. See, that is what I am saying. If you have come across a certain problem, where the poles are not separable in terms of the real values, definitely you can go ahead with this solution, this pattern. May I know each and everything is clear or not? Yes. Till this point, each and everything is clear or not? If it is clear, just write clear somewhere. Just write clear somewhere. Yes. Just write clear somewhere. Now, let me go into the next point. Again, let me recall the two governing equations of the SSM. The first was a state equation, the second was the output equation, and with the help of state equation and the output equations, we are going to analyze many of the things. Yes, so here goes. You can write either in terms of matrix, or simply you can write x dot is equals to ax plus bu, but nobody should have any doubt as such, they are in a form of matrix or linear algebra. So here goes x dot is equals to of a of x plus of b of u, obviously in time domain. Here goes the output in time domain is equals to of c of x plus of d of u. Yes, with the help of the given SSM, I am interested in finding the stability of the system. Yes, I am interested in finding the stability of the system. Although the matrix A, B, C and D together contains so many huge number of informations, including the controllability, including the observability, including the system's response, including the stability of the system, but the focus of mine is just over the stability. May I know what would be the conclusion we are deriving out of this? What conclusion we are deriving out of this? See, the conclusion which we are deriving out of this is, let's take the Laplace in the first equation, which is nothing but the state equation. So may I know what it would be? It would become s times of capital X, no? Once we take the Laplace of any time domain function, definitely the function itself gets changed. Agreed? Minus of x of 0, that is nothing but the worth of the state variable initially at t is equals to 0. And here goes is equals to of a, that is a constant, will remain a of x of s, and plus it becomes b of u of s. Agreed? So far I was using the transfer function approach, now again I am using the transfer function approach, because if we talk about the stability, how the stability of any given system is being used, first we find its transfer function. In transfer function, the initial condition has to be stopped, has to be killed, we will be doing it, and just we would be focusing over the roots of its denominator's polynomial. That would be the next criteria. So anyways, I would be forcing x of 0 as 0. Yes. So at least I would be able to get the x of s. In future, I would be feeding x of s in second equation, and I would be able to relate the output and input from there. I would be able to get the transfer function. So see here what is happening over here. See, it becomes si x of s It is in term of matrix. No, it is a form of matrix. So obviously the identity matrix got multiplied over here. I am not going into the great detail. Here it becomes A times of x of s. It is a matrix. It is a matrix is equals to of B times of, which is a matrix getting multiplied with another column matrix U of s. Agreed? My basic intention is to get the value of x of s. So what I would do, I would take the common factors out, and keep in mind the matrix multiplication does not follow the commutative law, and hence if the matrix is towards left hand side, it has to be taken common towards left hand side. If the matrix is towards right hand side, it has to be taken common towards right hand side. So here what happens? Here it becomes Si towards left hand side minus of A towards the left hand side. Definitely can be brought it out. Agreed? Till this point, nobody should have a doubt as such. So the component of the matrix which has been left out towards the right hand side is simply x of s. Agreed? Now here goes towards the right hand side the matrix B, which is getting multiplied with the U of s. Yes? No issue as such, sir? No issue? Yes. Now my basic intention is to get the value of x of s. So what I would do? See, it's not simple algebra where the Si minus 1a would be taken towards the denominator side. That's not possible with the linear algebra. Yes, so what I would be doing? I would be multiplying Si minus a inverse towards the left hand side of the left hand side, and similarly I would be multiplying Si minus of a inverse towards right hand side. So end of the day, if Si minus a gets multiplied with the Si minus a inverse, obviously it has to be a square matrix. It is a square matrix. A is a square matrix. I is a square matrix. It would be a square matrix. And keep in mind, inverse is possible only for the square matrix, and that concept is again coming back, which we have seen as a part of mathematics. Yes. So the result which we are getting is simply going to be x of s is equals to Si minus of A inverse. Nobody should write this factor towards right hand side, otherwise the complete conclusion would be yes, x of s is equals to of Si minus of A inverse into of B into of US. Anyways, this was the conclusion from the first equation when the initial condition was dropped, and that is what the basic conditioning with the transfer function. Till this point, nobody should have any doubt as such. What I would be doing, I would be taking the Laplace in the second equation, and I would be feeding xs is this. So now, taking Laplace in the second equation. In second equation. Taking Laplace in second equation. Yes. Yes. So now what happens at the output side? I would be taking the Laplace both other sides, so it becomes y of s is equals to c times of x of s, and here goes d times of u of s. Till this point, nobody should have any doubt as such. Yes, but the x of s has to get replaced with this. So y of s becomes, see, it would be a huge outcome, but it's still important outcome. It becomes c now over here. Here the x of s is nothing but Si minus of A, which gets multiplied with the inverse. Yes, gets multiplied with B, gets multiplied with u of s, and along with this the d into u of s is also coming. And if you are interested in finding the transfer function, may I know how the transfer function would be calculated? Output divided by of input, but in linear algebra this can be written as y of s into u of s inverse. Agreed? Y of s into u of s inverse. No doubt as such. Agreed? No doubt as such. If this is the case, what I would be doing, I would be multiplying u of s inverse both of the side towards the right hand side. Yes. So now simply it becomes c See, my dear friends, keep in mind, many of the times it have come with the help of matrix A, B, C and D. How would you be able to calculate? How would you be able to calculate the transfer function of the given system? Easily you would be able to calculate the transfer function of the system. Transfer function of the system till this point. Yes. Nobody should have any doubt as such. So you would be able to get the transfer function of this given system. But for the time being, I am not interested over the transfer function. Yes, but this thing should be in your mind. This thing should be in your mind. Either you can by heart this formula, but I would request to each one of you, need not to by heart anything, at least in GATE examination. You can just focus over these steps which I have taken while calculating the transfer function. Agreed? But one of the most important thing, the stability. Which stability? Absolute stability of the given system is solely defined by the poles of the given transfer function. What does it mean by the poles of the given transfer function? That's nothing but the roots of the denominator. What does it mean by the roots of the denominator? The transfer function would have the two parts, the numerator's polynomial and the denominator's polynomial. If you'll compare the denominator's polynomial with zeros, whatever the roots you get, no, they are nothing but the closed loop poles. If all of the poles are kept towards the left hand side of the j omega axis, the system is going to be a stable system. If any of them goes towards right hand side, that's it. But here you can see very well, once you would be taking the reference of the each and individual component, if we'll talk about the inverse of Si minus of A, that would be the adjoint of Si minus of A, and at denominator it's going to be mod of Si minus of A. What does it mean of it? The meaning is quite clear. Towards the denominator side, you would have a polynomial, and that polynomial is nothing but mod of Si minus of A, and if you will compare with this as 0, by default you get the characteristic equation. Agreed? Till this point nobody should have any doubt as such what I am saying. And now if you have the characteristic equation, by default after the calculations of the roots of mod of Si minus of A is equals to 0, you would be able to comment over the stability of the system. Keep in mind, that is why the matrix A is being said as system matrix. Agreed? Agreed till this point, nobody should have any doubt as such. Sir, why we are multiplied with I? Anyways, now probably each and everything must be clear to all of us. Yes. What I would be doing, let me take few number of examples. Here comes the matrix A. Let's take the matrix A is 2, 1, 2 and maybe 0. Yes, 2, 1 and 2 as well as 0. Now, you would be having the homework, find the characteristic equation for this given problem. Yes. And similarly, more number of equations you will have. More number of matrix A you can have. Now you can have a matrix of maybe 3 cross 3. 1, 0, 2, 2, 0, 3 and 1, 0, maybe 0, 0. And again you need to get the characteristic equation for this given problem. Yes. Anyways, I would be stopping my today's video here itself, because I am going to take the plenty amount of problem based on the concept of state space analysis in tomorrow's class. And today most of us had to be busy with Dande's sir class, because the super marathon for the control system is already running in parallel with our global channel. So I would request to each one of you, the person who have been here, just switch it to our main channel and take the actual glimpse of the control system. And I need to break the video here itself, because if I'll go a bit ahead, so probably the student who would start attending the class from tomorrow onwards may not be able to understand. So probably the concept must be clear, what I wanted to communicate till this point, and thereafter we will be leaving today's class. So I have started stating the structures of the state equation as well as the output equation. The two different networks I have taken. First was the series RLC circuit. The second was the complex RLC circuit, where the excitation was the current. And my basic agenda was to convert this electrical system into the form of SSM, and that we have done it. The second, if you have been given with the transfer function, with the help of transfer function, how will you judge the ABCD or SSM model, and that also we have done. So around 3 to 4 number of problems we have taken. The first 2 problems were based on the concept of canonical form, where the poles were pure real, and similarly once the pole have a certain complex component, definitely I cannot go ahead with the canonical form. You can see very well, you cannot keep the values as imaginary, so you had to go ahead with the SFG form. And even we have taken few numericals for that also, yes, like this. End of the day, what I was doing, I was calculating the transfer function if the reverse process has to be followed. With the help of transfer function, we concluded the ABCD. Now, if the process is just reverse, you know the value of ABCD and you wanted to know the complete transfer function, how will you get to know about it? So, obviously, such a intense or such a complex formula have come into the picture. But if we really discussing about the stability of the system, you need not to focus over the C, SI inverse, B and D. You just have to focus over this factor. And if we'll take the inverse of SI minus of A, it would be adjoint of Si minus of A, and at denominator it would be mod of Si minus A. Great. And if it is happening so, the stability would be solely defined by mod of Si minus A is equals to 0, and which would become a characteristic equation in future. Agreed? End of the day, few number of problems I have given for the homework, but anyways, I would be completing the concept of state space model in tomorrow's class, and that would be the probably end of the control system. We'll meet tomorrow with a great enthusiasm. Till then, bye-bye, take care, thank you very much.